name is Mikenzie, and welcome to my Metalworks backyard. Last time we talked about simple machines and how they make our lives a little bit easier. This time we're going to be talking about alternative energy, how it's converted, and how it can be used to supply energy to a house. Let's get started. Whew. Sure is bright out here. I wonder how they turn the sun's rays into electricity. Let's take a look.
Solar panels contain photovoltaic cells made from silicon, and they transfer sunlight into electricity instead of heat. The photovoltaic cells are made up of a positive and negative film of silicon under a thin sheet of glass. When the sun beams down on the cells, it allows the electrons to break free of the silicon, and as they collect to one side of the silicon, they create an electric voltage, which can then be collected. The current is gathered by the wiring of the solar panel. This is called a solar photovoltaic array. All the solar photovoltaic array cables come together in a box called the fuse array combiner. Inside, it contains the connections to the inverter, which turns the DC electricity created by the solar panels into a 120-volt AC that can be used by connecting it directly to the circuit breaker.
So that's how they turn the sun's rays into electricity. Wow. But what about this wind? How do they turn the wind into electricity? Let's take a look.
A wind turbine has four main parts. The rotor consists of the blades, the hub, the spinner, and pitch system. These are the things you see on the outside and collect energy from the wind. The main function of the rotor is to generate the wind's torque and gain momentum off of it. The second component of the wind turbine is the nacelle. This is the piece that converts the wind energy into electricity. The wind enters from the hub and travels through the main shaft until it reaches the gearbox. The wind's energy is then transferred into the shaft of the turbine and then through to the generator. The generator is connected to the converter at the back of the turbine. This converts the energy into electricity. The largest part of the turbine is the tower, as it holds up the entire structure. And finally, the foundation. It's the ground right below the tower and keeps everything upright.
That's interesting. I never knew a windmill could make its own electricity. But I wonder, if wind can do it, can water? Let's see.
Hydropower is much like using the wind to create power, but instead of the force of air pushing a turbine in an open field, water is gathered behind a dam in a reservoir at an elevation so that when the water is released and gravity carries it down, it passes by the turbines, causing movement and creating kinetic energy that spins the turbines. Then, a hydroelectric generator converts the mechanical energy into electricity. The generator uses electromagnets, which are made by circulating the direct current through loops of wire around sheets of steel. These are called field poles and are put on the outside of the rotor. The rotor is attached to the turbine shaft and rotates at a constant speed. When the rotor turns, it causes the electromagnets, or field poles, to move past the conductor. This is what causes electricity to flow.
Wow, that's crazy how water and turbines can be used to create electricity. Maybe if water in a reservoir behind a dam can create electricity, what about water inside of the earth? Let's check it out.
Geothermal energy uses the same method as hydropower or wind, but uses steam to spin the turbines. The production wells are used to lead hot water or steam to the production plants. Rock catchers are in place to make sure that only steam or water is sent to the turbines. The injection wells make sure that the water that is drawn up from the well gets put back so it can be used again. The water or steam can be anywhere from 220 to 600 degrees.
So I was right. Water from inside of the crust can be converted into electricity. I wonder what engineers have been doing to make advancements in alternative energy. Let's look. Ooh, it looks like engineers have created a way for solar panels to collect energy from both sun and rain. Though the design looks like it still needs to be refined, it does still show a promising outlook for the future. And, after about a decade of research, the Google X Lab has created an energy kite. It looks like a plane. It's secured to the ground and it collects wind energy. Though it's still in development, it looks like it could produce enough electricity to power about 300 homes. These forms of alternative energy can be collected right in your backyard, or produced on a mass scale, and then sent to a grid, and then connected to your home. Well, that's all for this edition of Mikenzee's Metalworks Backyard. Today we learned how alternative energy is converted and used to supply electricity to a home. Don't forget to stick around for the next episode. That's all for today. Mikenzie out.